Hello and welcome to this virtual 2021 Spring Railway Modellers Weekend at Missenden Abbey. I'm Christopher Langdon and I would like to share with you my experiences in getting started with 3D printing. During this presentation I will tell you what you need to get started, including a description of the process starting with designing the model on your PC using computer-aided design software, or CAD for short, and how you can use that design to produce a 3D print. The two main types of 3D printer, where you can find further information, and how you can try out 3D printing without having to buy a printer. A few simple questions. Are you considering buying a 3D printer? Are you just curious about what they can do for the railway modeller? Have you actually got one and are saying to yourself, now what? And how do I get the best out of the 3D printer? Or are you interested in other people's experiences? It's hard to believe that it was 2 years ago that I'd completed 20 years and 50 courses as course organiser at Missenden Abbey. For my farewell weekend, I was delighted to receive a wonderful gift, a very generous gift, a 3D printer. At our Missenden Abbey railway modelling courses, we are always trying to introduce new technologies to our participants. We had our first demonstration of 3D printing technology in 2008. It was very impressive, but a very costly professional machine, and although the chap was able to demonstrate some wonderful models that he'd built of locomotives, it was not really practical at that stage. However, in 2013, Bob Gledhill, who is a professional CAD engineer but also a very keen and very accomplished railway modeller, showed us how technology was moving and introduced us to laser cutting, 2D, and to 3D printing. 3D printers are now cost a lot less and are affordable to hobbyists. The software to do the designs is also much more user-friendly. Moving on to 2015, Alan Butler of Model D started running his courses on 3D printing, and in particular he showed us how you could take a general works diagram drawing of a locomotive and you could transform that into a CAD file for 3D printing. He also started demonstrating the process of scanning figures that he used for resin 3D printing, and he's built a very successful business up on that technology. This is the Prusa i3 Mark III 3D printer. It came as a kit and I assembled it. It saved a lot of money. Building it was a lot of fun, and it's very, very beneficial in showing you, teaching you how the thing works. Like all FDM printers, it works by melting the filament through the extruder head and extruding it onto the moving heated bed. It's highly recommended by lots of modelers, and I would recommend it without any reservation. There are two different sorts of 3D printers, the one that uses the monofilament and one that uses resin. The monofilament ones, like I have, just takes the strand of plastic, is melted through the heated element, extruded by the printing head through a nozzle onto the moving plate, and the layers are built up to produce the 3D print. And this is fine for the majority of modelling that I do. However, if you want very, very fine detail, like for doing figures, then the liquid resin process is probably more suitable. This is the one that Alan Butler uses. It's just more complex, it costs more money, and there is some work to be done after you have printed the model you're making. If you want all the details, the Prusa website has everything that you need to know with all the pros and cons, and Prusa have just introduced a new relatively low cost resin printer. This shows Alan Butler on the left in the top hand picture, scanning David Brandreth in a bowler hat, and below you can see the models that have been produced using this resin casting process. It's super for figures, and Alan Butler's built a very, very good business up making figures using this process. Here you can see the printer during the various stages of assembly. The instructions that are on the small computer to the left are very, very good. They're all online instructions. You check it off as you go along, and there are places where you can ask questions and lots of answers come back. It's really very, very good indeed, and there's no problem with instructions. You're provided with tools which are mainly Allen keys, and there's no parts that are missing. Everything is there. In fact, they give you a copious quantity of spare parts as well. It does take a bit of time. It's not fiddly, but it does take time. The components are extremely well made, but the real advantage, as I've said before, is it shows you how the thing works, which later on is extremely useful. And here you can see my first print. It's a mounting bracket for a servo to go underneath a semaphore signal, and it worked perfectly. I was really very pleased indeed at the way this turned out. So, how does one go about producing a 3D print? Well, the first stage is to design it using computer-aided design with software on your PC. There are two popular versions of software: SketchUp, which is free and very, very easy to use, and Fusion 360, which is semi-professional, but there is a student license which I use, which is free. The simplest one to use, though, especially for a beginner, is SketchUp. Both of these softwares will produce a STL file, which is the standard file for 3D printers. The STL files have to be sliced to produce the layers. And the slicer produces the file for the 3D printer. The slicer is very useful because you can manipulate and multiply the number of 3D models that you want to print. You can also produce mirror images, so you do one design and then the slicer can take those designs and give you several copies of that design. And then you put the file to your printer and you just sit there and watch the printer, and I have to say it's quite mesmerising watching the thing going backwards and forwards, building up layer after layer until you get your model. So this is the first step. This was designed using the Fusion 360, but it's very similar using SketchUp, and that's what the drawings look like. You get a visual representation of the thing you're trying to model in the design software. Then you export it as an STL file to a file folder on your computer. Second step, we load the Prusa slicer, load the STL file from your file folder, and reorientate the object if necessary. The key thing to here is what part of the object is going to be printed first. usually it's the largest part of it that's going to stand up on, and the bigger the area on the bottom, the better it is for sticking to the plate. And you can produce the mirror images and multiple copies, as I've said before, and you then export the G code to an SD card. So you've converted your file from your STL, and done the slicing, converts it to a G code, goes onto your SD card, which you can then put into your printer. So the third and final step: turn on the printer following the instructions, insert the SD card into the printer control panel. I always do a first layer check before printing. There's a test program that you get in the orange control panel at the bottom, and it's worth doing that. It gets everything set up for you. Then select the file on the control panel and print. That's where the SD card goes. So what did I make? I made these servo mounts for signals that you saw earlier on. I've made some signal box lever covers that I found useful, very easy things to print. Then I've produced some sockets for the signal servo brackets so that I can remove the signals from the layout. Some end pieces for some control panels I've made. A soap dish for her indoors, that's quite interesting. And then lots of PPE bits for the NHS. So here are the servo mounting brackets. You can see on the left straight off the 3D printer, and then it's assembled onto the signal. These are DAPL signals. I removed the strange mechanism they used and replaced them with this. It works very, very well. Here's the lever frame with all the lever frame covers, the lever covers on there, different colours for different functions. On the left you can see 4 pieces of the chin guards for the PPE masks that I was making, and on the right an ugly picture of me wearing one of the face masks that we made, and I made about 86 of those, so the kind gift from Missenden has actually been very, very useful during this emergency, certainly at the beginning of it, in making headgear for the NHS. What did I learn? Well, building the Prusa printer was very, very straightforward, very enjoyable, and very informative. The online documentation was extremely good, very easy to follow. There were no missing parts, and the tools were provided. Setting up was okay. The first layer, though, is quite critical, and I spent quite a lot of time doing that, and I'd recommend that anybody else takes time to do this. It saves a lot of time if you get some dodgy prints, and you'll need some patience. You will need some patience if you're not familiar with CAD. And keep your filament in a cool, dry environment, because if it absorbs moisture, you're going to get indifferent printing. And don't buy cheap filament. You always get what you pay for. And here's some suggestions and ideas. Find somebody who's actually got a 3D printer. Ask them for their recommendations. What are the pitfalls? Which one do they choose? Why do they choose it? What software did they use? And would they be prepared to print a small test piece for you? You can then go get a free copy of SketchUp, fiddle around with it, try and draw something, give it to your mate, and he can produce it for you. Read Bob's Gledhill's Laser Cutting and 3D Printing for Railway Modelers. It's an excellent book. I've known Bob a long time, and he's made some really quite outstanding models. He's taught both the subjects at Missenden Abbey, and he also has a library of designs that you can print, so you can download his things, his stuff, and you can print them at home if you've got a printer and you don't really want to be bothered with all the CAD design. So have a go and see what you do. You don't need a printer. you can get free software, so you can build yourself, or you can design yourself all sorts of useful things for your railway, and hopefully somebody can print them for you. So, what have we learned from this? What are the conclusions? Well, 3D printers are valuable railway modelling tools, no doubt in my mind about that. You can produce quantities of things that you can't necessarily buy. I couldn't find anywhere that had those servo mounts, and when the smaller, thinner servos came out, it was relatively easy to build the mounts for them. In my opinion, CAD is becoming a basic tool for railway modellers, and the best way to learn it is to go on one of our courses. But seriously, it is going to become a basic skill. Most people are computer literate. CAD is not that difficult. It's getting much easier to use, and in the same way that you would do a drawing on the back of an envelope, now you do your drawing on your computer. You send the file to somebody or send it to your printer, and you've got the finished article. And they're reliable and a very useful addition to the modeller's workshop. And you do not need a printer to get started. So I hope that's given you a good insight into my first year or so of having a 3D printer, and hopefully you'll enjoy using one. Thank you.